All right, we are in Chapter 6 still, exponential and logarithmic functions. Today we'll be talking about Section 6.4, graphs of the logarithmic functions. In this section, we're only going to concentrate on identifying the domain of log functions and graphing log functions. We will not be graphing log functions with transformations. We're going to keep the graphing pretty basic. Okay, so let's first talk about the domain of a log function. So if you will remember, in an earlier section, we learned that the domain of the log function was the range of the exponential function, and the range of the log function is the domain of the exponential function because they're inverses. So if you will remember from an earlier section, the domain of y equals b to the x is 0. I'm sorry. Strike that. The domain of y equals b to the x. Sorry, I was highlighting the wrong one. Is all real numbers. But that happens to be the range of the log function. So the domain of the exponential function is the range of the log function. And likewise, the range of the exponential function is 0 to infinity. It has a horizontal asymptote at y equals 0. Well, that happens to be the domain of the log function. So the log function has a vertical asymptote at x equals 0. Okay, so it's kind of reverse. You can look at the graphs here. You can see the domain is all real numbers, and the range goes from 0 to infinity for the exponential function. For the log function, this is the log function here. You can see that the domain goes from 0 to infinity. There are no negative points or no negative x's. So from 0 to infinity, and then the range is all real numbers. Okay, so you can see that on the graph. So this is the basic shape of a log function. So let's talk about let's talk about the domain of log functions a little bit further. So if we're going to find the domain of a log function that is something other than log base b of x, such as these below, like what is the domain of log base 5 of x minus 2 plus 1? So what we know is what's inside here, what's inside that parenthesis, that is what has to be greater than 0. So that's the first thing you're going to do is you're going to set an inequality showing the argument greater than 0, and then you'll solve for x and then put that in interval notation, and voila, you have the domain. So let's do this one together. What's the domain of log base 5 of x minus 2 plus 1? So we're only focusing on this inside the parentheses. That is what we know has to be greater than 0. So we will add 2 to both sides and solve. And we get x has to be greater than 0. So that means the domain in interval notation is from 2 to infinity. No brackets here, just parentheses. Let's do the next one. We know that what's inside here has to be greater than 0. So x minus 5 has to be greater than 0. Add 5 to both sides. X is greater than 5. So the domain in this case is 5 to infinity. All parentheses again. All right, now I wanted to take it a little bit further and look at a couple of different ones that you might end up with in the homework so that you are ready. So let's look at this one. Let's look at log base 10 of 3 minus x. So I know that for the domain, the 3 minus x has to be greater than 0. So the reason I brought these into play is because there are rules for solving inequalities, and I just want to make sure you remember those rules. So if we were to subtract 3 from both sides, we get negative x is greater than negative 3, and then we have to divide both sides of the equation by -1. And hopefully you remember that that is a special case. When you divide both sides of an inequality by a negative number, you have to flip the inequality sign. So x is actually less than +3 because -3 divided by -1 is 3. So x is less than 3 rather than greater than 3. So the domain of this function is -infinity to 3. All right. Look at this next one. All right. So what's inside here has to be greater than 0. So to solve this one, I can see I have an x in both terms, so I'm going to factor that out. And that would leave 4 minus x. So I have x times 4 minus x. So then you're going to, what I do is I just set it like this. And so I know that x has to be greater than 0, but 4 minus x has to be greater than 0 as well. So if I were to solve that, I would end up with -x is greater than -4. And then I have to divide both sides by -1. And we end up with x is less than +4. So I know that x has to be greater than 0 but less than 4. So the domain is from 0 to 4. So greater than 0, less than 4. All right, so there was an interesting one I found in the homework like that. So if you run into something similar, there you go. All right, so that's domain. So now let's talk about graphing log functions. So log functions, if you will look, a positive log function looks this way, or an increasing log function looks like this. A decreasing log function looks like this. Okay, so we're just going to focus on graphing logs in this format, log base b of x. We're not going to add anything else to it. We're just going to keep it like this. Things that you'll notice about this. All right, first, b has to be positive. We talked about that before. And b can't equal 1. The function is 1 to 1. It has a vertical asymptote at x equals 0, which I mentioned that earlier. The domain is 0 to infinity, range is -infinity to infinity. We mentioned that as well. Now here are some key things. The x-intercept is at 1, 0, and there's a key point at B1, and I'm going to add to that, okay? There is a second key point at the reciprocal of b. The reciprocal of b and -1. Okay, you might find that helpful. Let's see. The y-intercept, there isn't one. It's increasing if the b right here, if that b is greater than 1, it's increasing. If this b is between 0 and 1, meaning it's a fraction that's less than 1, but it's greater than 0 because it's positive, because it has to be positive, then it's decreasing. Okay? So we can take these characteristics and use that to help us graph log functions. So to graph, you're going to draw and label the vertical asymptote, which is x equals 0. When this is when we're graphing log base b of x. We will plot the y-intercept, which is always 1, 0. We'll plot the key points, b1 and 1 over b, the reciprocal of b, comma -1. And we're going to draw a smooth curve through the points. Okay, and the curve will look like one of these two here. And then it says state the domain and range and the vertical asymptote. So let's look at y equals log base 2 of x. So let's list some things that we know. We know that the vertical asymptote is at x equals 0. We know that the x-intercept is always going to be 1, 0. So again, I just want to show you that's right here. All right, because we're only graphing log base b of x. We're not adding anything to it or doing anything drastic. Just log base b of x. In this case, b is 2. So the x-intercept is 1, 0. And then we have 2 key points. All right, the first one is b1, and b is 2 right there. So that's the point 2, 1. And I also said that there was another key point at the reciprocal of b. So the reciprocal of 2 is 1/2 and -1, right? We'll just go ahead and write the domain and the range because it asked for both of those earlier. So the domain, remember, is from 1 to infinity, and from 0 to infinity, rather. I apologize. And range is all real numbers. All right. So this works better if you have a ruler. Okay. So the first thing that it says to do is to plot the vertical asymptote at x equals 0. So that's what we're going to do first. So at x equals 0, I'm going to plot the vertical asymptote and label it. Okay, and then the next thing it says plot the x-intercept. That's step 2, plot the x-intercept, which is 1, 0. And then plot the key point, which it said was b1. But I also said there was one at the reciprocal of b and -1, so I'm going to plot both of those. So we have the point over 2 and up 1. And then we also have the reciprocal 1/2 and -1. So there are the points. And if you look at your b is 2. It is greater than 0, so this is increasing. So this graph is going to look like the one on the left. This graph here. It's going to look like that. So it will look something like that. Okay? And I'll just show you. Obviously, let's go to Desmos. Let me see if I can find my Desmos calculator here. So I could do, for log functions, you hit functions, and there is a log under miscellaneous, log base A, so log base 2 of x, and you can see, and then you can find those points. That there is a 0.21 there and a 0.1/2 -1 as well, but you can see the basic shape there. But the key points you can definitely get from those little formulas I gave. All right, so let's look at another one. Oops, I lost the graph. Let me draw it back here. All right, so let's do log base 4 of x. I'm just going to go ahead and draw out the coordinate plane. Okay, so we have a vertical asymptote at x equals 0. We have an x-intercept at 1, 0. We have 2 key points. We have 1 key point at b1, b is 4, and we have another key point at the reciprocal of b, 1/4 and -1. And we'll go ahead and say the domain, which is always 0 to infinity, and a range from negative infinity to positive infinity. And since 4 is greater than 0, I know it's going to be increasing. So let's plot. So we've got x equals 0 is our vertical, not horizontal, vertical asymptote. Then we have the point 1, 0 as our x-intercept. And then we have the point 1, 2, 3, 4 up 1 as one of our key points. The reciprocal 1/4. So go over to 1/4 and down 1. There's the other point, key point. And then we know it's increasing, so it curves like that. Right? So there's that graph. Alright, so let's look at one where it's decreasing. So let's look at this one. We have a vertical asymptote at x equals 0. We have a x-intercept, which again is at 1, 0. We have 2 key points. So the first key point is at 1/2 and 1. And the second key point is at the reciprocal. The reciprocal of 1/2 is 2. So there's a point at 2 and negative 1. Domain and the range, those are always the same thing. So if you think about this, if you think about it, vertical asymptote, horizontal asymptote, domain, and range, they're always the same for that basic log base b of x graph. Again, we're not doing any transformations or anything. We're just keeping it basic. The only thing that's going to change up is your key points and whether it's increasing or decreasing. All right, so oops, try a little bit straighter there. All right, so again, we have x equals 0 is our vertical asymptote. Then we have x equals, the point 1, 0 as our x-intercept. And then we have a key point at 1/2 up 1. So go over half and up 1. And then we have another key point at 2. So go over 2 and down 1. Now, 1/2 is between 0 and 1, which means it's decreasing. So I just want to remind you what that decreasing graph looks like. It looks like this one on the right. It's going to swoop down like that and go through 1, 0. All right, so it's going to swoop down. Let me do a different color so you can see. Swoop and curve like that. All right. Let's do one more. I've got y equals 1/4 x. So vertical asymptote, x-intercept, domain, range, that's all the same. So let's just write down what the key points are. The key points would be 1/4 and 1 and 4 and negative 1. So let me try to do this right here. Okay, so plotting, here is the vertical asymptote. I think I keep saying vertical asymptote, but just in case I've said horizontal asymptote in the course of some time in this video, that was a mistake. It's the vertical asymptote that is x equals 0. Okay, so then we have an x-intercept at 1, 0. We have a key point at 1/4 up 1. So half is halfway, and 1/4 is halfway between 0 and halfway. So go 1/4 up 1, and then we have the point 1, 2, 3, 4, and down 1. So again, it's going to swoop down. Oh, let me do a different color so you can kind of see the points and then the actual graph. And I'm going to try to do that again, make it nicer. It is a curve. There we go. It's a little bit nicer than the original one that I drew. So again, you can use Desmos. However, I think it's just as easy to do it by hand this way because there's not much to it. You know, you're always going to have this point here, 1, 0. You know, it can't cross x equals 0. And then you just take your b and plot b1 and then reciprocal b of b and then negative 1. And then, wow, you've got your graph and you're done. It's actually pretty easy to graph. So you guys try this one. Graph f of x equals log base 1/5 of x, and then state the domain and the range and the asymptote. Okay? And then when you're finished, unpause the video and we'll go over it. Okay, so let's see. The vertical asymptote is at x equals 0. The x-intercept is at 1, 0. The domain is at 0 to infinity. The range goes from negative infinity to positive infinity. So the only thing that changes is the key points. So we have a key point at B1. B is 1/5. So we have a key point at 1/5 and 1. And then we have a key point at the reciprocal. The reciprocal is of 1/5 is 5. So 5 and negative 1. And if we look at this number, 1/5, it's between 0 and 1, so we know the graph is decreasing. So let's plot our points and our asymptotes. So we have an asymptote, a vertical asymptote at x equals 0. And we have a x-intercept at 1, 0. And we have a key point at 1/5 and 1. So 1/5 and 1, kind of estimate where it is about right there. And then I have a point at 1, 2, 3, 4, 5, and negative 1. And remember, it can't cross the horizontal asymptote. And so I'm just going to try to draw it the best that I can here. Try one more time. We do it one more time. There we go. There we go. So there you have it. And I believe that's all I have in this section. So if you have any questions, please let me know.